All right, recording. So, good morning. This is a special session in Nefio for kind of a workshop on how to build aggregated APIs in Kubernetes. And the reason this is relevant to us is because we're using it right in our Porch code base. So I will be going very little bit into the Porch code base. This is actually not about how Porch did it specifically, but how it works generally. So, let me just answer on Slack. All right. So I'll share my screen and just dive right into it. Let's see. Okay. So I hope everybody can see. Um, so first of all, what is a aggregated API in Kubernetes? Everybody knows I hope you know the basic components of Kubernetes. There's the kubelet, there's kube proxy optionally, and the kube API server, right? That is the heart of Kubernetes. The kube API server provides a RESTful API. Maybe I'll put RESTful in quotation marks. It's not always very RESTful, but the idea is that you have kind of structured URLs, and through those structured URLs, you can access all the Kubernetes data, which is backed in etcd. Right? So the kube API is basically a layer on top of etcd, right? It does a lot. There's a lot of code there actually, and we're going to jump a little bit into it because we have to use that code. I'll show you why. And it does support this mode in which it acts as a proxy. So it can handle the URLs, right? And the URLs usually look something like this. You can see this here, right? But it can send those URLs to another service, and that service can run inside the cluster, it can run outside of the cluster, it can run anywhere. And that is what we're calling the aggregation layer, right, in the Kubernetes code base. So it's just a proxy. It's just a proxy. However, if you go here to the documentation, right, which is the starting point of what you usually do, you're going to Google, how do I make a Kubernetes aggregated API? And you'll go here. And what you'll get here is very unhelpful documentation, I have to say. So the documentation here about configuring the aggregation layer is practically all about authentication, right? And authorization and making sure that you can make that delegate work, right? And it is very, very complicated, right? You'll have to get the certificates working on both ends. You're going to have to start your main API server knowing the certificate of your aggregated service. And yeah, it's complicated. Of course, maybe an obvious point here, you can implement your aggregated API in any language you want, in any style you want, as long as you adhere to what the kube API needs. I think doing that would be incredibly hard. I don't know of any project that did that. Almost all projects, what they do is use the API server code itself to build your own API server, so you can rely on all the machinery that's there. And there's a lot of machinery having to do with authentication, with codecs to wire things over the protocol. We'll talk about that a bit. There's a lot of work to be done there. But one important thing I want to say, that this documentation about the whole authorization, authentication dance that you have here, you don't have to read this. I did not read this, and Porch did not read this. Why? Because in our cases, we're bypassing that entirely by doing this. I'll show you here how I define this. So make this a little bit bigger. So really, to connect an aggregated API, you just have to create this resource. It's called API service under the API registration API. And you tell it how you want to access your aggregated API. So you can use, in this case, we're just using a service inside Kubernetes, right? So it's behind it, there'll probably be a pod, right? But here's the thing, you can just say insecure skip TLS verify true. And Porch does this as well, by the way. And then you circumvent, oops, you circumvent all of this. So for testing and even not for testing, right? Because Porch doesn't even handle right now the way we install Porch, we set that to true. So all this documentation here you can avoid right now, right? I haven't done this, do this properly, right? Because you'll have to, if you want to do this properly with authentication, you would have to install your Kubernetes cluster with those certificates, right? Here. So yeah, that might be a little difficult in production environments, right? Which is something you need to think about too. If you're running something like Porch in an environment, say that doesn't allow you to use that flag, right? For whatever reason, right? So you can't circumvent that. This is obviously a big security risk to do that because it means anybody can provide APIs to Kubernetes that do anything they want, right? So authentication probably is important for production environments, and it's something we'll probably have to explore regarding Porch at some point. Okay, so if this documentation is useless, which documentation would we use? Oh, by the way, I'll say generally, feel free to jump in at any time and interrupt me. I'm not looking at the hands raised, so just go ahead if you have a question. So if not this, well, what do we use for learning about how to do this, right? So the source is the best source, apparently, but I'll tell you why it's not a great source either, is the sample API server, right? This is published in Kubernetes, and it's supposed to provide you an idea of how you can actually create your own aggregated API, right? So this is what I looked at in some depth. Unfortunately, the documentation here isn't so great. They tell you exactly how to run those certificates, if you want to create your own self-signed and attach it. But again, you can ignore all of that just by using that flag. Here's the thing. This server is this example sample server that they're providing here does something that is kind of useless. So if we go to the actual code here, you'll see there's code here for configuring the API server. That's very useful. And then there's something called a registry. So the term registry here in this context means not what you think it means. It's not a container image registry. Registry is what they're calling here internally is the storage backend for your resources, right? That's what it means in this case. So you have an API on top of a registry, right? That's the backend. So if you go into the registry here, you'll see that they're importing something called generic registry. And that's how they handle everything, right? So you might think, oh, the generic registry is probably some kind of general scaffolding that you can just fill in and inherit or do whatever you need to kind of make it your own, right? And that's a reasonable guess to make. That was my first guess. And in fact, Porch code also uses this generic registry code. And let me show you where this code is and why this is a red herring, okay? First of all, you see that it imports it from API server. So let's go to another repository, another Git repository here called API server. This is where we're importing code from. This repository, right, it's a generic library for building the Kubernetes aggregated API server. Okay, so you think, okay, this is great. This is all the tooling we'll need to do this, right? If we go into the actual generic API registry, and there's a lot of code here, right? I'll talk about that, some of it. Here's generic. This is what we're importing, the generic registry. So you'll say, okay, great. This is what I can use to kind of do that. We have underneath the registry, there's something called stores. So there's a one-to-many relationship between this registry and stores. So each store can handle different entity types, right? So you can have some entity types stored in one place and others elsewhere. What I found out is that this generic registry is not generic at all, or rather it's generic in a specific way. It's on top of etcd. That's my point. This generic registry is called generic, but they mean generic for etcd. So this sample API server, what's not very clear if you just look at it, is that it's on top of etcd. And you can see it even more directly if we go here to, so again, I'm back in the sample code, the sample API server. So if we look under artifacts, will I find it here? Nope. I don't exactly remember where the Kubernetes resources are. Would it be under package? No. Thought it was under artifacts. Give me a second. Oh, probably here. Nope. This is an example of, oh yeah, here it is, that actually deploys it. So this is the API service. You can see, again, they're doing this flag here to skip the TLS verification. But we create the service. Here's the deployment itself. So if you look at how they deploy their actual server here, see there are two containers. The second container is etcd. So this is where everything kind of came together for me. I realized that they're actually storing everything using that quote unquote generic API server on this etcd instance. So it's not the Kubernetes built-in etcd, right? That's part of your Kubernetes instance, right? Your cluster. But actually they're having it inside their container and they're storing stuff there. So what this means is if you go to this sample API server and you're looking for help on how to build aggregated APIs, this sample is very strange, right? Because this whole sample is about storing things in etcd. And then you have to ask yourself, well, what's the use case here, right? If you're storing things in etcd, why not simply use CRDs, right? And indeed, this is just a very awkward way to do kind of the same thing that CRDs use. With some more flexibility, right? Because you can actually delve into the RESTful API and do some custom things. Like they add here some sort of custom validation. I think that's the only useful thing added by this sample API server. But my point is that if you go here, it's not documented anywhere. The word etcd isn't mentioned here in the README. But if you dive into what this actually does, it stores things in etcd using the quote unquote generic API server. So what this means is that this sample API server is not incredibly useful for use cases where you want to build a generic API server that uses, aggregated API server that does not use etcd, right? Which I think is what most people want to use an aggregated API server for, right? In the case of Porsche, of course, we're storing everything in Git, right? Not in etcd. So, and if you're doing your own aggregated API server, you probably have another backend in mind, right? So we will be using some code here, especially in the configuration. But again, I did not find this incredibly useful. Now, we will be importing a lot of code from here, from the API server package repository. It is very, very complicated code. And as you dive into it, and I tried my best, you go kind of into the history of Kubernetes, the Kubernetes API server here too. There's a lot of cruft here, a lot of older stuff. You can see kind of how new Kubernetes features were added on top. For example, sub-resources, right? So things like the status sub-resources was not something that existed originally in Kubernetes, but it was a feature that was added later, and it was non-trivial, right? Because the whole point of sub-resources is that you can do atomic updates to them without updating the main resource. And they kind of had to change the whole request structure here and the whole semantics. So I keep saying that this is RESTful with quotation marks because the semantics for all the REST operations are non-trivial, I will say, right? And they also add a whole bunch of their own HTTP verbs that are kind of special. And each of them has their own semantics. Some of them are simple, some of them are very complex. So we're going to kind of go into some of them one by one in a minute. So yeah, I'm just setting the stage here in terms of what we're using. So we'll be importing a lot of code from here and to build our own Go-based aggregated API server. So what we end up really doing is our own API server is very similar to the standard Kubernetes API server. It uses a lot of the same code, right? So imports it. So we're getting something that's very built in the same way that Kubernetes itself is built, right? And that's good because we want this delegation to work as well as we can, the structure of the URLs, the supported verbs, the error messages. There's also a very specific way to send errors here that we'll talk about a little bit. So yeah, importing from here will do a lot of the heavy lifting for us. Unfortunately, this is an adventure. This library has many layers. Just the code for handling HTTP request is thousands of lines long, imports a lot of other code. There's a lot of kind of generic reflection-based stuff. And as I said, a lot of kind of layers of history as well. It's very hard to look at the documentation here, at least it was for me, and understand how everything kind of connects together. So a lot of trial and error. All right, so let's kind of look at what I did and kind of build up from this and try to get there. So I hope you remember, some of you saw the TKO example. So as I said, TKO now, it started with a gRPC API, and I added this Kubernetes KRM API using an aggregated server. So can everybody see this okay? I hope it's large enough. So here I can get resources. So I can get, actually, I put all the TKO resources under a TKO category. I'll show you how to use that too. So I can just get TKO, and it'll get me all of them. So you can see here, this is the log on top. So you can see the live log going on here. So I see there are 4 TKO resource types. So there's plugins. Actually, we start here at the top. It's a little too big to see. Sorry, let's make this. Oops. So kubectl get TKO. So on the top here, we have all the deployments. And then we have all the plugins, and then we have all the sites, and then we have all the templates. We're going to delve into these entities in more depth and see how they're implemented. So yeah, so just getting those, or I can get a specific one. I could get like all the templates, and then I can get, an individual template like this one. And I can output it in YAML. Right, so here's the template, metadata, here's the spec. Has an empty package here. And I can do describe.
Did you do field selectors, Paul?
Partially. I'll show how to do that as well. It differs for different REST endpoints, and it means different things. But no, I did not do that. I did kind of a very bare bones one, mostly, yeah. But I can show you how to do that as well. Yeah, so you can do describe as well. And you would actually get documentation here too, because all of this is based on OpenAPI. I'll explain how that figures in as well. So yeah, you get the resource version. I'm not using creation stamp here, and there's a UID kind of that I constructed. Yeah, so this works. You can also do updates, and you can do apply. That's a very complicated semantic that we'll get to, but let's do edit. So edit is, so here, yeah, we can say change this metadata. It was edited.
Did you do
right?
both server-side apply and client-side apply?
Yes, you absolutely can do server-side. Yeah, and server-side is much simpler, actually, the semantics. So the semantics for updates are by far the most complicated. Well, we'll keep those for last, because I struggled quite a bit with getting that working properly. Okay, the other ones are a bit simpler. So yeah, you can see we have basically a complete Kubernetes KRM facade over that. Other little things, this list here, when we get list, and we'll see that lists if we get all the templates. By the way, too, like if I do get deployment, this will show me the Kubernetes deployments. So I have to do .tko. Like the full thing is .tko.nefio.org, but you don't have to do anything, the whole thing. You can just put as much as you need to disambiguate it. So this will show us the TKO deployments, right? And the columns here too, this is something that you control and how they're shown. And another interesting thing is chunk. So scalability is a concern here and how you manage it. So let's say if you're getting a list of like 1,000,000 objects, so it actually does it by chunk size. You can give it a chunk size here. I gave it a chunk size of 1, and you can see in the logs, it kept getting this continue. So one by one, it just kind of scrolled page by page. I'll show you how that's implemented as well. There are so many little edge cases, right? Like testing all of this. There are all these little things in how kubectl works. And as Wim mentioned, when you do an apply for an update, there's actually a server-side apply too that has completely different semantics from the client-side apply with kubectl. So all these things, have their weird edge cases and non-trivial. Okay, so that's how the API looks. And by the way, you'll notice that my API, I did this purposely, is not namespaced. So all of these resources don't have a namespace associated with them. That was just a design choice. You can do it with namespaces, and that's a little weird. I'll show you how namespaces work as well. It's non-trivial. or rather, I would say it's easy to use, but kind of weird how they solved it. Okay, let's look at the actual code, how this is built. So starting at the top, how this was all packaged. So there's this API service thing. So you can just apply it as is. And, definitely for testing, you should use this insecure thing so you don't have to work with it. You'll have to set up a service as well. And there is some RBAC stuff, right, that you need in order to create that API service. I'll tell you that because I'm just doing a POC, I just gave cluster admin to my service account. The example does show you how you can fine-grain this a bit more and which exact permissions you need, so you don't have to open absolutely everything. So here under workloads, so that service, this is the actual service that I'm deploying. I chose this port just randomly. So if I go back here, 50052, this is the port that I put for the API service. So that's my target port here. And this is just really a regular deployment, right? It just has a container and just runs it. So there's some configuration here for which backend I want to use, Postgres, blah, blah, blah. There are a few other ports, and you can see that the Kubernetes API is just another port. I have a gRPC API, I have HTTP API. There's another port here for distributed logs, and that's it. So it's remarkably simple on this end, right? You really just have to create this extra API service resource. Pretty straightforward, right? The code is where it's not so straightforward. So let's look at the code. So if you remember how the TKO API works, it just has a backend. So pluggable backend, it's using SQL in this case, Postgres. And then under APIs, I have the various clients and servers that I use. So we have the gRPC server, a gRPC client, and we have a Kubernetes client and Kubernetes server. That's what's interesting for us too. So let's see how we built those. I'll start with the same way we start with KRDs, where you have to define your resources. So here they're under KRM. And this is a very familiar thing. If anybody built a CRD, you kind of, using Go, you kind of do the same thing as what I'm doing here, right? You define your types. You add annotations for KubeGen, which we'll talk about. A lot of these will be very, very familiar if you worked on CRDs. Actually, almost identical. I'll explain what we need to add here and why. But you'll see in most cases, for our types, we add type meta and object meta, right? That's to make them compatible with runtime object. You don't have to do this. Actually, you can create your own objects that do not inherit, do not use the standard metadata and object meta, right? The object meta is like name, generate name, there's a namespace, right? All these things. You don't have to actually use these. You can create your own aggregated API that does other kinds of resources, but they'll be more limited. There's a lot of things in Kubernetes that do expect these, right? For example, if you're doing apply with updates and things like that, it will look, at, the resource version here, right? So there are all these parts of the Kubernetes machinery that do try to look for these dynamically. And if they don't find them, then that feature just won't work, right? So you could potentially, if you want to add REST endpoints to give other types of objects, you can do that with an aggregated API server, but you won't participate as a Kubernetes resource, right? So I can't think of many use cases that you would want that, but that's definitely possible if you just want to use the API server to access things with a client, but you don't want to participate, in the cluster resource world, right? So a lot of this is structured in ways that you recognize. So we give all our different types. There are a lot of limitations for these that have to do with, on the one hand, things that you can generate a deep copy to. This is the generated deep copy code for all these. But if something doesn't work there, I'll show you. You can actually supply your own deep copy code. So technically, you can put anything you want in the data here. It does have to be, another limitation, that it has to be JSON marshallable. And people do this code a lot and don't think about it. You just have to add these. Actually, and the JSON name has to match the lowercase camel case version of the Go name. Otherwise, you will get errors. Why is this JSON? So here's the thing we have to understand. The entire API server is based on REST. On JSON. That is the standard wire protocol. And even though I've seen code in the API server that lets you install other codecs, I could not find any other codec being used. JSON is the natural language of Kubernetes and has been from the start. So a lot of times when we tend to work with YAML manifests. That's actually something that came a bit later in Kubernetes, but that's an entirely client-side thing. It's just to make it a bit nicer for us to work with kubectl. But the API server speaks JSON, not YAML, right? And that's why we don't have any YAML tags here. YAML is never participating on the server. So
one thing you also have to do product buffs, by the way. Because your delete collection will not work without it, I think.
We'll talk about that. That's a lot of what the API server does for us. Actually, we won't have to delve into that at all, luckily. That's something that the code does for us. So we'll never have to think about.
But I mean, if you look at the kubectl, I mean, I had to generate protobuf.
You could put code for protobufs here. You don't absolutely have to.
If you want to be compliant to the client, you have to.
Well, if you want to be able to handle updates, right? So you can add tags here for the protobuf. That's kind of a separate topic. It's true for CRDs as well. The reason why you want to add like specific protobuf fields here is that if you change this while development and your clients have not updated the code, those protobuf field numbers will be generated automatically and you might have a mismatch. But assuming that you're publishing a library and you're giving this code v1 alpha 1 and you're not going to change it, like if you want to change it, you're going to do v1 alpha 2, right? If you're going to have a stable code base, you won't have to change that, but it's good practice probably to put protobuf names here, right? To just kind of give it a fixed number for protobuf, right? Because internally,
the API server these days does both JSON and protobufs, by the way.
Yes, you know what? I'm not going to get into protobufs here, but you are right. You are correct. It does do both. Right, but we're only going to be working with JSON. That's the only thing that will concern us. But you're right. I try to make this the code base here is tried to be as minimal as possible, right? So I removed everything that's not absolutely necessary, but there's a lot of other stuff we can add to validation. Okay, so a lot of this looks very standard. You'll see this optional field here. So this is not for the, so this is, okay, KubeGen. I'll jump a little bit to something else here and we'll get back to this in a second. So how do I actually generate code from here? So we're using KubeGen, right? And I'll mention that a lot of times we just run the KubeGen script. Sorry, it's called KubeCogen. Sorry, not KubeGen, KubeCogen. But they've kind of deprecated the old approach. What they recommend doing now is actually sourcing the CoGen shell script and then calling individual functions. These are the name of the individual functions. So here's what we're generating. We're generating the helpers, which in our case is only the deep copy code. Then we're generating OpenAPI. This is probably new for you guys, and I'll explain why we need to do that. And then we're generating the client code, which is very standard, right? The client code, by the way, is what I'm generating here under gRPC client. Oh, sorry, under Kubernetes client. So this is just the standard client code generated. I'm actually not using this code at all, but anybody who would want to use these objects can use that code, unless they want to use the dynamic unstructured client. So yeah, that's just the standard code gen code. The Open API, this is the new thing that was added here, right? And I'll go into this in a second. But going back to our types, this optional is used by that Open API generator, right? It's not used by the gen client, and it's not used by the gen helpers. Another thing that the Open API generator uses is the documentation. So these comments become important. They will come into the Open API/Swagger documentation for our RESTful API, right? So it's basically the same thing we've done with CRDs, but there's a few extra special comments here. And one thing I'll show at the end is, this is something Wim, remember when I talked about possibly changing in Porch, instead of putting YAML, putting just raw resources. This is how I handled it here. I'll just show you how you can circumvent the code generators. So I have something called a package. It's a struct that just has a list of resources. This thing is just a map of string to any, right? So all of the entity types here are packages. So we have 3 entity types: templates, sites, and deployments. All of those are packages. So you see in their spec, the deployment spec has something called a package. And this is the package. A package is just really a list of resources. But my point is, the reason I did it this way is that if you try to just generate code from this using a CodeGen, you will get lots of errors, because CodeGen doesn't know how to work with unstructured data, which is just a map of string to any. So I had to provide my own custom copy into functions, which are very simple, right? But still, CodeGen can't deal with them. And also, I had to provide my own Open API definition, because that code generator would also fail. And this, again, if you've ever worked with CRDs, you've seen this. This is exactly it, the Open API spec for CRDs. So here I just do a special spec that allows you to, it's just an array of objects, and the objects are just generic objects. So yeah, you can do this. Just
I have no problem with that, by the way.
Yeah. Okay. Good. Yeah. So
I
yeah,
think because you have used the raw object, which already has these defined, I think, so that the generators can work with the raw object instead of.
Yeah. My point here is that Open API totally supports this. It's only the Cube CodeGen that doesn't support this. It doesn't know how to generate something like this. But this is all I needed to do. The moment I just provided these functions with the proper names and signatures, I don't have to do anything else. There's no magical annotation. The code generators will see that this function already exists and just not generate it. So that was very easy to do. So why did I generate this Open API thing too? And I'll show you how it looks. So this is the generated Open API file. It is huge. It is a very, very big file. And basically what it does is create all of these automatically. And you can see the description here is exactly that Go comment that I had there. So it just generates a lot of Open API, or they're sometimes called Swagger, right? It used to be Swagger. But what this means is that my aggregated API server will publish its own self-documentation, right, using Open API. So this is all that code that does that, right? So this becomes all my RESTful endpoints, right? So that's generated for me. But as I said, there's some limitation to the generator. But if you're trying to do something that the generator can't do, no problem. Just provide your own Open API definition for that type, and you can just do it manually. So not a big deal, right? So so yeah, the optional thing is also important here, because that is used in the Open API generator to add. It means it will not add it to the required fields here, right? So I'm not delving deep into Open API here. I think anybody who's worked with CRDs probably knows this fairly well. It's a bit complicated in the Go code, but you know how to do this manually. So the code generator just does all of this for us within its limitations. Okay, so that's kind of how I work with types. Oh, maybe one tiny little thing to show. So this is how we add schemes. There's something more that I had to add here, something about an internal API version. So you might have seen this in some Kubernetes code before. So what is the internal API version? So as you know, every resource is defined by GVK, right? Resource type. We have our group. In my case, it's tko.nefio.org. We have our version, which is v1 alpha 1. So many projects always stay forever as v1 alpha 1, right? But eventually we hope to get to v1 with any project. And of course, we can support multiple versions per group, right? If we want to kind of support older API versions. There is a special, a conventional, it's by convention, it's not any technical aspect to Kubernetes per se, but a special version which is called the internal version. And there's a, here's the const that's defined in the API machinery code, and it's __ eternal. So within the API group, you can have an internal version. And why do we need that? What is that for? It's mysterious. It's something that's not versioned, right? What does that mean? And why do we need that? I'll show you that we do need this. And it's pretty complicated to explain why. And I'll be honest, I don't entirely understand why. We don't need this for CRDs, but we do need this for API servers. And you'll see what I'm doing here is this is kind of the standard scheme builder code that you've probably seen for CRDs, where you add the known types to your group version, right? This is v1 alpha 1. So this is kind of the standard practice that we do for CRDs, but you see that I added another scheme builder here that adds everything to the internal API version, right? So I added 2 scheme builder code here, right? And I'll show you how we use them in a little bit. Okay, I've been giving you a lot of background here. Let's jump into the actual code, because that, I think, is what will be interesting. So as I said, what I try to do here is to be as minimal as possible. Right. And I think I'll very humbly suggest that my code here is a much better starting point than going to that API server sample code, which uses etcd, as you know, behind the scenes, because I'm really going to the bare bones and doing exactly only what needs to be done. So let's look at how we construct the server itself.
Can I ask just one question? Maybe it
Sure.
was asked already, but I joined later. So, you said that you started from the sample API server, which, it is not so well documented that it is kind of misleading in several ways. But there are 2 other projects which kind of helping you and can.
You mean this one?
So the API server runtime and the API server builder, basically the 2 are kind of connected together. The API server runtime, I used it. Of course, it is not so maintained, so that is one problem with it. But at least it can help you to generalize or so it's already solved some of the problems which you have to solve manually if you are not using it.
Well, sure. I did start by saying that you can use this if you want. As you said, it's a work in progress. I don't know how well maintained it is. I see they have had, 3 months ago a commit, but I don't know exactly what that was for. I think just upgrading Kubernetes API version. I don't know how well this is maintained. If you want to use it, you can. I did not find it very useful for the same reason I don't use the kube runtime for my operators. The code is already complex. If you want to add another API layer and dependency, you can. It's up to you, right? I'm going into the kind of the more bare bones and trying to show you how it all works, because you're going to have to handle the semantics anyway, right? So yeah, that's up to you. You can use other projects if you want, and hopefully they'll mature and be great. I tend to want to understand what I'm doing first before I use something else, so I can actually evaluate that other thing and know if it's actually helping me or adding more dependencies for me. So starting the API server is looks something like this on the high end. So if you're using the API server code, and I'm porting here from here I am importing the server code. Oh, I just noticed I'm importing it here twice. Oops. I'm going to fix this live. Thanks for your patience. Okay, so what you do is you create a config. From the config, you call new to create your actual server object. You give it a delegate, which I don't entirely understand what it is, but all the code that I looked at uses an empty delegate. And the most important thing is installing the API group. So what this does is give all the information to the API server about all the endpoints, REST endpoints that it needs to handle. And for every endpoint type, it gives you kind of the backend, what they call the registry code, to provide the functions that implement those objects and their semantics. So you see, I'm creating this API group here. This is my function with a REST options getter, and I'm providing my own backend. Okay. The generic REST options getter is part of that generic code that I mentioned that has to do with etcd backends. I have not found a way to avoid it, right? So I am using some code from that generic backend, which has a lot of etcd kind of information. You can mostly ignore it, as I said, because we're not actually using etcd as our backend, but you'll see a lot of information there about etcd. I create my stores, one per entity type. These are the 4 entity types I support. And this is where it gets interesting. I create an API group info. I provide it with my scheme and codecs. And the codecs here, there's a codec factory too that we have to initialize. The parameter codec is used for the REST parameters and the URL. The codecs is where I saw the JSON codec. So I have not seen the aggregated API server use protobuf. I do know, of course, that the main Kubernetes API server does support protobufs, but I think when it delegates to us, it can use whatever codec we provide it. And as far as I've seen in all the example code I looked at, it only uses the JSON codec. So that's why I'm kind of like ignoring protobuf entirely. But protobuf is basically supported by all the types, so those should work. I just haven't tested them. Okay, so this is kind of the map of all entity types. And you'll see internally, it actually uses the plural type, right? So for deployment, it would be underscore deployments. This is also something that sometimes confuses people with, we identify all the types by GVK. And the kind usually has, it has an uppercase name, right? But internally, Kubernetes also uses resource names, right? And those are the same resource names we have here in kubectl, where we can type get deployments or get deployment, right? I just don't have these in the default namespace. So those names are actually kind of the internal resource names that are used, and we'll see them. Those are the primary ones we're using here internally, not the kind, not the GVK. So the reason is that GVK really relates to resources, and you don't have to support resources. You can also provide these non-resource objects as well, right? But since all our objects are, in this case, standard Kubernetes resources, so yeah, anyway. But the registration here happens based on that plural name. So for the template store, yeah, never mind, but it's like it's going to be just templates in lowercase. The plural usually is the primary name. The singular name is kind of an alias. All right, so this is kind of where I tie everything together here for registering the various types. The config is where things got a little bit funky, and as I said, there's a lot here having to do with etcd. So. And I haven't found a way around it, right? So I just provide empty stuff to the etcd configuration. Porch does this as well. The sample API server uses etcd, so of course it uses it. But yeah, if you want to use the kind of code here, it does have it. So when I do a new recommended options, this first string that I'm putting empty here is actually the etcd backend name. And since I'm not using etcd, it's just an empty string. Yeah. It's a very trivial point here, but it took me so long to figure out what was going on here. Here I'm providing, this is a little bit annoying, but all the code that I saw uses this legacy codec, which has to do with that kind of JSON registration. If you go here, they'll say, don't use this anymore. This is deprecated, use other codecs by type. So there's another way where per type, you can give it its own codec, but I don't know how to use that. And the config here doesn't use it as well. So I have to use this. Here's some code that I commented out where eventually, if I want to use certificates, this is how you would do it if you want to secure everything. So you do it during the configuration of the server. This is important too, the OpenAPI config. So you can see here the legacy OpenAPI before they move to v3. So you can register both. Yeah, this is where I imported my own code and installed my scheme, right? So these are all the types that we generated with the code generator. This is where they're actually being applied. So this means that my API server will be able to publish the entire Swagger / OpenAPI documentation, right? Self-documentation. So that's included here. So yeah, you register a type if you want to support the kind of old style OpenAPI. It's the same code, but just here I do default OpenAPI v3 config. Here's OpenAPI config. My scheme, this is where I registered all my types. But you'll see here that remember where I showed you that we had the internal version? If you're doing CRDs, you never need that internal version. If you're doing an API server, you need that internal version. And I found exactly one place where we need it. We'll get to that when we get to updates. That's when you need it. In the Porch code base, you'll see they did the same thing, but they did it a little bit differently. Let me show you the Porch code here. So in Porch, if anybody looked at Porch and was confused by something, maybe now I can give a kind of an explanation. So we have, so under the Porch code, we have v1 alpha 1, which we have all our types. But then you'll see in the main direction, there's more types. It's basically the same types twice, as far as I can tell. And I think what the Porch developers try to do there is exactly put that internal type here. They decided to put all the types twice. I'm not really sure why. I don't think you need to do
for
that.
Conversions. Total, I think you don't really have to do that. I think this is only there for conversions. So when you basically change the API to a new version, this is how you generate the conversion.
Okay, so that's why they
logic.
Okay.
So you don't really need it if you're not upgrading or something like that, right? So I for example don't have to use it if you don't have a second version.
Yeah. In my case, I'm definitely, this is just a POC. I'm not doing any conversions. So I'm just adding the exact same
But
types to
yeah.
the
Yeah, but you don't. In my code, I don't even have to do this.
So we have to do this here, absolutely, and I'll show you why. It has to do with updates. Okay, so
I don't think so, but okay. Yeah.
I would be very happy to remove that code. The sample service does that as well. So okay. All right. So
but I built some my own API server code, so that's why I don't have to do it.
Okay, yeah. When we get to the point where I'll show you where it's used, if you can explain to me how not to use that, I would be very happy. Okay, so this is where we do the we configure the server. Now let's look at the actual stores that we create, where the entities are stored. That's where the logic kind of is. So if you go back to the server again, this is where I map these. I create these stores. So I create a store per entity type, and the way I did this, because all my entity types kind of share the same basic semantics, I created one master class for everything. And I use these function pointers, right, to give the only to be able to inject just the specific logic per entity type. But all the rest, they share their logic. So I'm going to go over all the shared logic and kind of explain the semantics one by one. Now, here's an annoying thing. To get everything to work, there is one interface that you have to support, and that interface is called storage. So here's the kind of master file that I went through a lot, and you'll see here it's under registry REST. right? So this is under the API server registry, and this is kind of the most generic code that you need in order to support a store. The most generic code is this interface. All you need is new, which creates a new object, which it internally uses reflection to kind of figure out the data type, and then you need destroy for destroying your store. This is the bare minimum you need to support storage. Obviously, there's no logic here, so this is not interesting. The way they handled all the other functionality is by a very long list of interfaces. And the way this works is that all these interfaces are optional. If you support any of them, you might be able to support certain storage functionality. And some of them overlap, actually. There are some that you can't use together with the others on purpose. Like you have to pick one interface or the other. But there's a lot of stuff here, a lot of different interfaces. And the documentation is here, you can see, but it's pretty opaque sometimes. It's not always clear how this figures into the whole dance. So what I did was try to implement them one by one and kind of see which ones I actually needed. Again, trying to get to the bare minimum, while also providing hooks that if I want to expand in the future. So if people are a little bit confused by what this is kind of a way and go to kind of validate interfaces. So the way you do it, you create a var and just try to convert it to an interface. And if that interface doesn't work, for example, this interface will fail, and even my IDE shows that it fails. It says, oh, you're not implementing certain functions in the interface, so this will actually create a panic. But this is kind of a nice way to validate, because Go interfaces are dynamic, right? They're only runtime assured. This is a way to add that kind of runtime assertion that your type actually supports an interface. So you can see all the different interfaces that I support here. There are a whole bunch that I don't. For example, I don't support watching. That's kind of a complex feature that might be necessary in some cases, that you can actually watch resources and get updates on them. In order to handle those semantics, you need a way to watch kind of the backend and get kind of events from your backend that will tell you when things are updated, et cetera, right? So a watcher is, in my case, not something that I can implement, so I didn't, right? But you'll see a lot of other interfaces that I do implement. There's all these kind of metadata providers. There's a lister, a getter, a creator, an updater, and a patcher. Those are kind of like the big parts of the semantics. And there are other auxiliary ones that we'll talk about. So a lot of basic ones are very simple, right? So as I said, new, you have to provide just a new instant of your object, which the machinery kind of does a reflection for to get some information about it. This is an important one, namespace scoped. So this is just a Boolean that you returned. And if you want your store to be namespaced, I do not. So I put namespace false, and that kind of completely changes the code path to avoid sending namespace information. And we're going to talk about how namespace information. So I'm not doing that, but I'll show you how you use namespaces. It's weird. Here's my kind. Here's my short names that I can provide. So these are kind of the things in kubectl that you can give shortcuts. Like if you want to use SVC instead of service, right? So you can give it short names here. So they're just aliases. This is the categories that you want to belong to. So in kubectl, for example, I had this category TKO that I put everything there. There's a built-in category called all, right? So when you do get all, it'll show you a whole bunch of resources, not all of them, but only those resources that got registered in the all category. So if you want your resource to appear in all, you can just add it here to the array of strings, right? I just have one category, which is TKO. This is the singular name, right? Which, as I said, it's lowercase, kind of the name of the resource, which is another type of alias, right? So you don't have to provide it here, but if you do, you will get that kind of singular name. The GVK, that's important. Actually, it's not that important. I'll show you. You can have the same store support multiple GVKs. For example, if you want a multi-version store, right? So you have this function here, accepts group version, which you can actually control which resources gets accepted. So if you want to support two different versions, you can check for that here too. So again, a lot of these functions are optional. It kind of, if you implement this interface, you'll get this functionality. If you don't, you'll get another functionality. So yeah, if you want to implement accepts group version, you could potentially support multiple groups and multiple versions with the same storage backend, of course, you can just register in your server for different types as well. So you can do that as well. Okay, new list, right? This creates a new list type object for it. And that list object does have to handle the usual semantics. So if we go here under types, if you create a list, right, there's the list meta that you provide instead. So that will be expected if you want to support lists. And I'm not going to start by the list function. I'm actually going to start with get, because I think get is the simplest one. So the semantics for get are that you do get potential get options where you can choose a resource version. And yeah, that's it. So you can specify a specific version of an object. You'll notice that in the signature of the function, you get a name, right? And now you might be asking, well, okay, so all I need to do is fetch my object and return it, right? That's pretty straightforward. But I'll already tell you that you also need to, the errors that you provide for all your interfaces here have to be compatible with the API errors library, right? So don't return error code in any of these functions just directly. Make sure to wrap it at least in one of these API errors code, right? Because those make sure to return a REST status, and the internal machinery expects that. So it's going to look for that. If you do return your own generic error, you will get an error at the end, but it'll go all the way to the client. You're going to get kind of a weird internal server error, and it's not going to be a nice user experience, right? So if you want to provide a good user experience, make sure to return API errors from everything, right? So yeah, you can just wrap so for example, if you have a generic error, you can just wrap it with internal error. That's a 500 error, of course, and it will just wrap it with your code, right? So where's the namespace, right? Okay, I get a name. But you'll notice I'm not even getting like a GVK or anything like that. So that's why it's kind of weird. If you want to accept, if up here you want to accept different kinds of GVKs, you're not getting that information here. The get function only gives you a name. So which version will you return? Will you return the latest version? Probably, right? So the semantics here are very flexible. So, but it means you can do kind of strange things with this, right? But here you only get the name. So the first thing you might ask, where's the namespace? I'll show you where the namespace is. So I'll go here to the API server. Yeah, let's look at the generic server code. Oh no, sorry, I went to the runtime. So here, this is the API server code. Under package, under registry, generic, which again, remind you, the generic registry is an etcd registry. It's not truly generic. So yeah, here's under store. I did look at a lot of this code. Oops. Namespace. Yes, okay, here it is. What they're doing to get the namespace is they're calling their own function namespace from the context. Okay, this is what I wanted to show you. The namespace is provided inside the context, and they have a special function to retrieve it from the context. Some of you are like, what's going on here? Okay, so the context package, which is a very basic Golang construct, is used for cancellation, right? So you can provide a context to any function, and you could potentially cancel that function right externally from the client of the function can provide a kind of cancellation for it, right? Obviously, you have to do your own work to actually look at the context, but that's what contexts are for. Contexts also have room for user data. And if you look at the Golang documentation, they say, please don't use this, right? Because it's a very awkward way. You're saying, oh, I'm already sending a context object. It's a place for me to kind of tag along and insert my own special data. That's not the right way to do it, right? Change your whole architecture to actually have that data. But they provide it as a way to kind of solve problems, right? And what they did here in Kubernetes API server is they solved a problem, which I think is that I'm guessing that namespaces were added later. And when they were added, they didn't want to change the whole code, so they just injected it here. That's my guess. So what it means that if you want to retrieve the namespace, you retrieve it from the context. So it's there. So even though it's not part of the signature of the function, that's how you get it. Weird, right? But yeah, simple to do. You just have to call that utility function to get it, but that's where you get the namespace if you want it. So in my case, I'm not using the namespace. If you're using the namespace, pretty simple to get it. So what am I doing? I'm actually just taking the data from my backend and translating it to the KRM. So I'll show you, for example, how it works for a template. So here's my get function from the template. I'm going to my backend. I'm getting the template, which comes in kind of the backend struct. And then I'm converting the template to KRM. And I do want to show you how this looks because there's a few tiny little subtleties here. So this KRM template is exactly the template I showed you earlier on, which I generated code for, right? Just like if it was a CRD. And I'm filling in the API version and kind because they're not filled in automatically. You know, if I just create the struct, I'm giving it the name, the correct name. I am filling in the UID field. Now, I don't know if you actually need the UID. It's part of the metadata. I'm not entirely sure where it's used. It's not used for updates. If you're doing an updates, it's actually going to test according to a resource version, right? So the resource version is important for kind of flagging the specific version of your KRM. UID, I'm not exactly sure where it's used. At least in my use case, if I don't put UIDs, I find no loss of functionality anywhere. So I can't tell you exactly. And here I'm updating.
Yeah, it's a validation. It's a validation check, I think. All right. So what you should not. There is a check about it, right? So you should never accept an update on a resource that has a different UID, for example.
Yeah, but that's your own semantics, and like that's not enforced anywhere by the API server. So
no, it's your own logic. It's your own logic, but that's how the API server is using it at the moment.
So
which is what
mine doesn't.
No, the generic API server.
Oh, the generic API server? Yeah, maybe with etcd. Maybe it's like an etcd UID. Maybe. I don't know.
But it's a generic practice of APIs, right? So you always allocate the UUID, right? And that's your unique identifier to store it and to look up
stuff. I'm just saying it's a field you could use, but there's nothing here technically that requires you to use it. I haven't found it.
Now, I think the client, if you don't set it, I think kubectl client has a problem if you don't set it.
Well, I don't have a problem. I removed it and everything worked. So the only thing that I really need.
I think there are some issues with kubectl client. If you use certain clients, you will hit issues, I think.
So again, I did everything that I wanted to with kubectl client, and I haven't found it. If you can find exactly what needs it, please let me know. I didn't find where it's used, but yeah, it's there if you want to fill it, and it's usually pretty easy. Honestly, if you have a resource version, you can just put it there as well with some sort of prefix. You know, that's what I did. I just created a UID with my type. Internally, Kubernetes resources tend to use a UUID, but even the Kubernetes documentation says you don't have to do that. You can just do whatever you want for your UUID. For your UID. Yeah. So there's no real guidelines about when this is used. I haven't found out when it's used. Resource version is important. That I will talk about when we get to updates. So yeah, I do have code that kind of translates back and forth from the KRM and the backend representation. It's pretty straightforward. I will say that for the resource version, what I do is I take my my updated timestamp and turn it, just format it as a number. So you do need some way to identify versions of your resource, and that is for the update mechanics that we'll get to soon. Okay, so get is very easy. Let's go beyond get. Get is simple. I will mention that you actually have another getter interface that you can support. You can't support Barth and West, but there's something called getter with options, which just I think is an older style options. Instead of this options data, you just get a runtime object. And I think that lets you provide your own custom get options, which I'm not sure when you'll ever use. kubectl doesn't use them. I think if you have your own custom client, you can inject your own options there. So I haven't used that. By the way, there are things that you cannot do in kubectl. We're going to get to one of the operations here. kubectl cannot do all the API server things. Some things can only happen with your own custom code. That's kind of interesting. Okay, so get is easy. Let's take a look at delete, which is also easy. And so here's the delete code. The one thing about delete code is that you want to check, there is an option for dry runs that you just want to make sure that if a dry run is enabled, that you're not doing the actual deletion. So that's pretty trivial. There also is an option for one of the options here. Let's look for deletion is when you, so there's a grace period. So the delete operation could happen immediately if you give a grace period of 0. But if you give it, say, a grace period of 10 seconds, you say, oh, I don't mind if you delete it within the 10 seconds. So if you want in your own semantics, you can do something about that. Yeah, older clients actually don't provide that. So that when older clients provide nil for options, it means they mean for it to delete it immediately. So that's just something mentioned in the documentation. Also, there's interesting, do you return the object that you deleted during deleted or not? And there's actually something that you can handle here. There's a function called delete returns deleted object. And if you return true, that means it is expected to be returned, right? That's not always the case. So you have control here over that semantic, because in some cases your backend might not support that ability if you're just deleting without getting it first atomically or whatever. Okay, so that's delete. It's pretty straightforward, I think, as well. Except, yeah, there is also a delete validation function. And again, that's kind of optional to make sure that what you're deleted is valid. And yeah, that can be injected by the API backend. Validation is kind of a big topic on its own. I'm not going to get into it too much. I'm just going to briefly touch it. But yeah, if you want to know more about validation, that's kind of where the sample API server comes in. In my opinion, that's the only interesting thing in this code base, is to look at how they inject validation to the API server, so their own custom validation. So you could provide that as well. I'm not going to delve into that. That's kind of an extra feature. Okay, so deletion is easy. Let's move on to listing. I'm kind of going over these in order of complexity. List is kind of complex. And the reason list is complex is that we are not using a streaming API with JSON, right? gRPC does support streaming with protobufs, right? But even then, Kubernetes uses, the API server uses a paging-based approach. That means that when you do list, it cannot return 1 million resources, right? That will not fit into a JSON request. So the way it works is it gives you a max count of how many objects it is open to returning. And you can give it an offset for a page. Unfortunately, this means that you have to call list several times, and depending on how your backend works, it means it's not atomic, right? So you're paging, but you might actually get, for example, duplicates, right? If like an object has been deleted meanwhile, then the whole list could change, right? So there is some control about making that as stable as possible. And the control is based on this continue thing that you return. So your offset and max count are integers, I think. Yeah, limit is an integer. And the max count, I forget where it is. Oh, limit is the max count. And the offset, actually, where you start is not a number. It is a string. So that means you can use that string however you want. If you want, it could be just a number of the resource if it's sorted in your backend list, or it can be some other revision or key or anything else. So you can handle the semantics of paging in your own way, right? All you have to do is return some sort of continue string, and it's up to you to how to handle it. So it all depends on how you store your objects and what options you have for sorting and things like that. In my case, I'm using a SQL backend, which is sorted. So my continue here is just the number of where I stopped the offset. right? But the client doesn't know about that. The client stores that continue string and just gives that string back to me when it wants to continue. And I just know how to continue from that place, right? Yeah, and here I'm handling cancel. So that's one thing to think about lists. There's another important thing to think about. Here, by the way, is the field selector that you talked about when I think regarding lists. So regarding get, you can handle this again. So if you don't want to return all the fields, you can actually select them various ones. I didn't mention this in get, but you can do this as well. So if you don't want to return all the data, right? So I ignore that code. I always return all the data, but it's pretty trivial if you just want to return specific fields. Okay, this is where things get a little bit complicated. How much do I want to get into this? Actually, it's not that complicated, right? So here I just go over all my items from the backend and convert them one by one and look at the max count to make sure that I don't continue. If I hit the max count, I do set continue for the result so that the user knows how to, yeah, there are more results and you can continue. I do mention here something very tiny, but I think it's really just specific to my implementation. So because I'm using SQL queries, right? With a SQL query, you can give it a limit, but if there are more objects, you don't know. SQL query doesn't return a value, hey, there's more items for you. If you got exactly the items you need, that's kind of an edge case where I might return continue, but that continue will not return any values. So I just mentioned here, that's a tiny optimization that I'm missing here, but I think it's pretty trivial. Anyway, yeah, that's very specific to my semantics, but it's a good demonstration that your own project will have its own semantics, right? Your own listing semantics, your own getting semantics, your own creation semantics. And your goal here is really to translate your own semantics to Kubernetes semantics, right? I'm going to get into update at the end, but oh, there's another important part of listing that I forgot. Okay, so when you return a list, right, when I do get TKO and I get this list, do you see that it comes as a table, right? I don't have to return it as a table. I can do output as YAML, and then you get this kind of nice YAML over everything, right? But the standard format is a table. Now, this is something you might not have known, but this table is handled on the server side, right? It's not just a client thing that the client takes the YAML and converts it. The server actually has to return a special table object. And the way it does, it converts items into tables. Why did they separate this into a separate function? Why doesn't list just return tables? Because convert to table actually works on single objects and not only on lists, right? So if you return a single, so if you do get pod, right? Do I have any pods here? I don't. Yeah, but if you get a single item, this function is called as well. So this function, you see it gets an object. That object can be a list or it can be a single. So in your own code, you have to check for both of them. So if you get a list or you get a single object, it doesn't matter. You return a table object. And this isn't too complicated, but you do have like table options. So you can say, oh, I want you to give me headers or not. And also tables can include the objects with every row. So you can embed the objects in the table or not. So if you want to optimize correctly, look for those options. And yeah, here I'm making sure that I got a list. Yeah, this is something I also found out the hard way. So when you return the table, so you have a list. So when you call list, you return a list object, right? This returns an object, which is a runtime object, but it should be of type list with the list accessor data, meta. But for table, it returns a meta table object. But that meta table object might not have the list information that you got from objects. I found out the hard way that you have to copy these. So when you do I mentioned here, if you just do kubectl get, it expects to see these. If you do output with YAML, it doesn't need these. But I found out, yeah, it doesn't give you any errors. It just doesn't work. So I found out the hard way through a lot of debugging that I just copied these from my input to my output. Anyway, how do you create your own list? So I'll show you again with templates. So with my template object, here's my table function. So I just create a meta table object. if headers are necessary, I provide the headers. And the headers use the Open API type plus format specification, but this isn't complete. It's actually a very minimal version of Open API. So it does not support all the Open API types, but it supports basic things like strings. And if you give it a date type format, it will automatically do this thing where it gives you the date time. And by the way, I also, through trial and error, I found out this is always UTC. It always translates everything to UTC, so you cannot give it time zones. So unfortunate, but yeah, the user will always see UTC if you provide it this way. But yeah, here I create the individual cells and the headers. And if I wanted objects, then I embed the object in each cell. Okay, so tables are actually pretty straightforward. But yeah, the only thing to know about is what I said here is that the conversion to table can happen both from single objects and from lists. And you have to pay attention to both of those edge cases. Right, so that's tables. There, before we get to updates, which is the complicated one, I want to show you one optional interface that ends up being really complex for a weird reason. And that is deleting collections. Let me find it here. So we talked about delete. There is another option called delete, another interface that you can implement here, which is called delete collection, or the collection deleter is the name of the interface. I mentioned here, this verb cannot be called via kubectl, right? So when you call kubectl delete and even give it a selector, this is not what's going to be called. It will actually be calling delete on each one of them. It'll be calling list and then delete. When is this called? This is a special HTTP verb that can only be called from client code, so not from kubectl. However, and that's a little bit surprising to me that they didn't add that functionality to kubectl, because this is a very efficient function. The way delete collection works is that you give it kind of the options that you want to filter on, and it will delete everything. And this could mean millions of objects. So it's designed to be very scalable, right? Instead of deleting individual objects. So if you need to clean up a lot of objects, this is the one that's going to be called. And here I got inspired by that sample API server code. They handled it in a much more complicated way. I have my own utility, but basically what I'm doing here is I'm doing the list, but I'm deleting it in parallel. So I have a thread pool, right? Because there's room for optimization here, right? Because you don't have to delete them one by one. You know you're deleting all of these, so you can actually do whatever you want to be efficient here, right? If you have like a SQL backend, you can just do one query that deletes everything, right? So however it is you work, you can do this very efficiently. This is a room for being for optimization. So in my case, yeah, I just did like a thread pool, and I just delete them in a thread pool if you want to see how that works, right? Okay, but yeah, this weird optimization is not available with kubectl. If you want to test it, you're going to have to write your own client code. Otherwise, I don't think there's anything.
So Tal, is the delete collection of the same type, objects of the
Yes.
same type?
Yes,
Okay.
yes. It's all of these are for a specific type. So this entire code.
Okay.
So when you register the server, you give different stores per type. So every store has its own code, right? So every entity type. And entity types can be multi-versions. So you can support potentially multi-versions of each type. But I would say probably in most cases, it might be better to have a different source for every version. Kind of up to you how you do that.
Okay.
Yeah, and the sample code.
Well, if you do like delete namespace, for example, everybody gets gold.
Yeah.
Right? So Attila has been helping me on that. So delete namespace is kind of calling this to all the servers, by the way.
Yeah, that's I think part of a garbage collection, right? The kind of ownership thing, right?
No.
Not?
No, because if you do a delete namespace, right? If you have an object attached to the namespace, it should be deleted, right? So it's an indication to.
So basically, the namespace controller is implemented in a way that it is using the delete collection API call.
I hope
and this
so.
This is where actually this protobuf sterilization thingy is coming. It's happened. So that somehow there is a bug in the API server, or I don't know, but you have to have protobuf sterilization available for that specific.
And I think Tal doesn't have this problem because he doesn't implement namespace. But if you do implement namespaces,
Yeah.
you will hit this.
Okay, that's interesting. So the source code that I looked at, sample API server, said very specifically that this is never called from kubectl, but they might be wrong there.
It is not the kubectl. It is the
Okay.
namespace
No, no.
controller. So the namespace controller, which is running in the API,
Okay.
so in the Kubernetes, that is the controller.
Yeah, but by the way, I am using protobufs here. It's just like registered internally. I just don't care about it. It's just like handled automatically for me. So anyway, yeah, so there's room for optimization here, right? Okay, let's get to the big one, which is, oh, I forgot create. Sorry. That's also a little bit important. So before we get to update, let's talk about creation. And important thing to note here, people who don't know, that kubectl create and kubectl apply, a lot of times we use them interchangeably, but they have very different semantics, right? Especially apply is very complicated. It has server-side semantics and client-side semantics, which are specific to kubectl, and they're different, right? So create is when you're really creating an object from nothing, right? The idea is that you're creating something new that's not existing before, and you would get an error if that object already exists, right? That's kind of the point of the creation semantics. So they're pretty straightforward, right? And the code here is rather boilerplate. So I'll just mention some things that you have to pay attention to. First of all, I notice you absolutely, for this to work, you absolutely have to have metadata type objects. So if you're doing your own object that's not a resource, that won't work. So you can test for that. There is a feature, because you're using object meta. It's not a feature people use so much, but usually when you create a Kubernetes resource, you give it a name, right? You give it the GVK, and then under metadata, you give it a name, and probably also a namespace, right? If it's a namespace object. You don't have to give it a name. You can give it a generate name field instead. And that means that the name would actually automatically generate it. That could be useful in some cases. So that's handled here too as well. So that's not handled automatically by the API server. And the reason for that is that you might have your own system for generating names, right? But there's a default name provider that just adds a UUID to it. So yeah. So if that's important for you, that's a feature you can handle here. Again, you don't have to handle it here. You can return an error, say, hey, I don't support this generate name feature, but it's pretty trivial. Yeah, there are hooks here that I'm kind of just, I'm not using these hooks, but I'm just kind of following the code. There's again validation code that can be ejected for create that I'm not going to get into here because it's its own topic. Dry run again, make sure that if I'm doing a dry run, I'm not actually creating objects. And at the end, I'm just creating the object. So create is not too hard, right? But there's just that thing to think about. Oh, and you do have to return your object after it's created, because you're part of your creation process. You might have created all this metadata and other things, right? So you have to make sure to return that object after you're done. All right. So that's create. And again, just like get, there's like another named creator. So you notice that the create function does not get a name. It's expected that the name is here. But if you're implementing other kinds of objects that don't have, that don't inherit from Metabase, I guess that's what create, this named creator, is for, right? But you can't implement both functions at the same time. So I just use this underscore as a placeholder. So that's another code path you can take. So that's creation. Now let's get into update, which, as I said, is the most complicated one. And update is complicated because this is where you're trying to do something atomic, right? So the idea with an update, with an apply, is that you want to make sure that what you're changing is what you know you're changing, right? So that's where that revision comes in. And the way it works is different client side and server side, right? So the server side version of this would do kind of that update automatically. The client side version always involves getting the object first, right? And when you get the object, it will have that revision. Then you do your changes, and then you call, if it's in the case of kubectl, you call apply, which will call this update, right? So client-side version is always two operations, right? First getting and then applying. And with the consideration that in between, there might be a new revision, right? And the semantics are up to the server, right? If the server says, hey, I have no problem with you updating to an old revision, it can accept that, right? It's kind of your own semantic logic about what to do with that, right? You might say, hey, sorry, there's a newer revision and I don't want you to change that newer revision, right? It's kind of like a git commit, right? So the semantics of git are if you're trying to merge and if there's a conflict, then you have to handle that merge conflict yourself, right? So those kind of semantics are entirely up to you here. And you're given the tools to return whatever error you want, right? According to that. But there are other aspects here too, right? So update can also optionally create an object, right? So if you're trying to update an object that isn't there, it should be created. And that's why usually when we do kubectl apply, the reason it's usually interchangeable with kubectl create is that all those objects allow you to create the object if it doesn't already exist, right? So just doing apply is the safest thing in those cases. But not all objects have to behave that way. You know, most of the Kubernetes objects do, but there might be objects that say, sorry, you know, I can't create something out of anything. Update is only used for updating, right? So that's kind of up to you as well. And I'll show you that there's a function. I forget where it is, but there's another function where you can return a Boolean that says that if update allows you to create new objects. Okay, but here's an interesting thing. Even though the options, you might say, hey, I don't want allow you to create an object, there's an extra flag here called force allow create. So, and I think with kubectl, you can actually add that flag that says, hey, even though you're not allowing me, I want you to create anyway. But again, you can ignore that flag here. You can just say, I'm not going to do that. So yeah, so there are ways to work around the standard behavior as well, which is kind of weird, but you can do that. Okay, so let's say I'm updating an object and I'm not creating one. Here's an interesting thing here too. The function, you see, gets a name of what object I'm actually updating or creating, right, if I'm allowing for that. But I'm not actually getting the data of the object itself. But where's my data for actually updating? Like all the other functions, I get just an object runtime, right? Why I don't get it here? What they actually give you here is a function to retrieve that object, right? So it's called the object info function, and then I can call updated object, and it gets me that object. And I don't entirely understand why they did this way, but here's what I found out. You can read my note here. So if I do server side, when I tested it with kubectl apply server side, my code worked great. But I found out that if I'm not doing the server side code, and this is when maybe you can help me understand this. I
overlooked something. I also do it, but I do it under the hood, so I forgot about it. So I do use the internal as well.
Oh,
so,
okay. Yeah. So I don't entirely understand why this is required this way, but apparently if you do client-side updates, which is what we usually do when we use kubectl.
Because so you are sending in the annotations, you are sending this last applied changes, which is basically a calculation from the client side what is actually changed, and then so it is going to be applied there. On the if you are using the server side applied, then everything should be handled on the server side, of course.
Right. Let me go maybe into.
So this is why, for example, if you are having huge objects and you would like to apply them, then so for example, if you are using the etcd, then you will hit this limitation even on the metadata side, because it will fill up the last applied changes or something annotation, which is going to be really huge.
Yeah. Let me maybe show it to people so we understand what we're talking about. Yeah, that's where I was going with my guess. But I don't have a complete picture of what's going on. Sorry, I don't see it in this pod. Well, why don't I see it here? Okay,
I think because you have created so that, yeah, or you can check the deployment and then.
You have to do an apply. I think this object was there. You have to do an apply of a new object.
I think it'll be inside a deployment, maybe. Oh, Okay. Yeah, here it is.
Here, yeah.
Let me expand this a bit. Yeah, so kubectl adds a JSON version of the whole resource so it can handle the previous version of it. But yeah, you see the issue here is that we do have the API version, right? It's not an internal version. It does have the information here. So again, I don't have the whole story. I know it has something to do with this, but again, I don't know why.
The internal version, I think it is used for storage versions. So basically, it is just like for the CRDs that you have to specify the storage version and you have to do these conversions between the versions. So basically, I think this is the only thing where it is used.
Yeah, it has something to do with conversion, but again, I don't know why we need conversion. Where conversion fits in here, right? Because I'm getting data from the client, and that object that the client gives me does have a version, right? So maybe there's some feature here that I don't know about that we can potentially support.
You can
but
support multiple versions with the same API server.
Yeah.
So
okay, but if that
Yeah, so
version
from the
doesn't
moment-
exist, why aren't we using it? Yeah.
Yeah, but if you don't do conversion, so did you generate conversion rules at all? Probably not, right?
I guess so. I guess I just wonder that if I'm giving an explicit version, why does it need to try to convert it? But anyway, I don't know.
Oh,
Again,
because
I don't know
if your storage, yeah, okay.
Yeah,
I guess because
don't
we
know.
are don't really trust the client, so this may be the the situation here. So that,
Okay, this might be going a bit too deep for some people here, but
Yeah.
my point is that if you want this to work properly for all potential clients, it means that conversion is happening here. Again, I don't know exactly why. We have some guesses here, but the point is that this object sometimes will come with that internal _ internal API version, right? And in order for that to work properly, when we registered everything, right? Because this function, again, because I'm not getting the object directly, I'm relying on the machinery to fetch that object for me. And internally there's some conversioning happening, which I can control. It means that I had to put everything under that internal type, right? So, and the errors I got were very unclear. I had to do a lot of trial and error until figuring this out. But once I figured this out, it was pretty trivial to do. All I had to do was register all the types on that internal, in the schema. So it was really just adding this line here, and then magically, suddenly everything worked for me. So odd behavior on my end, but pretty easy to solve, right? And I tried to document this everywhere I could in my code here so people will understand why that happens. Why that's happening. The sample API server does it, but it doesn't explain why it's doing it. So not very clear there. Okay, so if that part is handled at this point, so updated object, as I said, returns the actual data from the client, but it's based on the current object, right? So the current object will be empty if this is a create, right? But if I'm allowing for again, if I'm allowing for update to work with empty objects, which means allowing for creation of new objects, that will be null. But if it's non-null, it should be non-null if I actually have that object. All right. Sorry, I explained that awkwardly, but I hope you understood that. But those semantics are actually checked. So if, yeah, so this will, sometimes this is null and sometimes this is not null, but it has to be the correct thing. So it should only be null if you're doing a create on update. Anyway, if you do something wrong here, you're actually going to get a sensible error to the client. So that's nice. But as I do, I call it here updated or new object because it can be either. And even internally here, so I'll show you, this is kind of the last part. I know we're a little bit over time, but I'm really towards the end here. So I have either an update or create function. So most of my entity types have very simple update semantics. So I only have a get or set for the backend CRUD, right? So in CRUD, I just have, you either set something new, and then I can just check with the revision information or not. The only entity in my backend that has a different semantics is deployments. because my deployments do have atomic updates. They support atomic updates, and that's exactly for the specialization workflow, right? Where you might have controllers that are doing some specialization, but they might be taking time to do that specialization. So they want to make sure that nobody else is changing it while they're changing it. So the correct workflow, in my opinion, there is to lock that object rather than allowing all these parallel updates that might be updating each other at the same time, right? So in order to support locking, I had to provide my own semantics. So the deployment update semantics that I have here, I'll show you. So I provide an update function, right? So again, with templates, for example, which are much simpler entities, I don't provide an update function. I just provide a create function, and the create function has no problem creating it again. If it already exists, it just overrides it. So those are very simple semantics there, because again, these are the semantics that I define for my backend, where I said templates are not changed very often. You don't have to lock them or anything like that, right? If somebody wants to update a template, they can update it. But with deployments, I do provide this update function. And the way it works, I have on the back end, I have this start deployment modification, which gives me a modification token. And when I'm done, I can do end deployment modification. And that actually, it locks it. So while between the start and the end, I'm actually locked. I can cancel it when I'm done. And I also have a certain time window when which I can end it. If not, it'll be canceled automatically for me. But here is where I do the resource versions comparison and make sure that what I was given actually matches the current state of the version, right? So if somebody is trying to update something that was already changed, I will return an error. And actually, the error I returned is just a conflict, right? So that is the 40. What is the conflict error code? 40. Anyway, 409. Okay, yeah, so the 409 HTTP code. But my point is that the semantics are entirely up to you, right? So you have a lot of flexibility for how to handle it. For example, I decided that if somebody already changed it, you'll get an error. You can try to do a best effort for the client. You can try maybe to update it anyway. Say, oh, somebody already updated, but since your update is newer, I'm going to take your update, right? My point is that's all I'm trying to say here, that semantics are entirely up to you. And there's kind of a lot of flexibility here in terms of what to do with those semantics, in terms if you want to support create on update, if you don't, and how you actually want to handle those updates. And if you want to play again around with it, the server side semantics are very different. And there's some documentation about it if you want to look into it. But it basically works. So you can do kube control get, store it locally, change it, and then do a kube control apply. But as I pointed out, you can just do kube control edit that does all of those together. So that's kind of cute. If you do kube control edit, it does exactly that. It just puts it in a temporary place, lets you edit it, and when you're done, it does an equivalent to kube control apply. So that's a nice way to test that everything works. And of course, if there's an error, you'll get an error. It'll get, for example, that the revision is incorrect. That's it. I think I really covered everything I wanted to cover, but there might be some little edge things that people have questions for. So please go ahead. I know we're over time. Sorry, I kind of knew that it would go beyond an hour and a half, but please, if there are any questions. There are none. So that's good. I think there was a lot here. The recording will remain if people want to go over it. And my source code is here too. I think my source code, the entire Kubernetes server really is just these few files. In my opinion, it's a much easier starting point than going to the sample API server, which is based on etcd. So you can kind of look at how I handle things and kind of build something on your own. If you really want to, you can use the this new project called the API Server Runtime, if you feel that this is helpful for you. I don't think you need to. I think the code that I showed you is not very complex, right? There's just some boilerplate code for configuration. And but once you have that set up, you just provide your own semantics. I don't think it's too hard to do. You just have to understand well what you're doing. So up to you. You have a few ways to go ahead with this. All right. Well, I really hope this was helpful. Yeah, if you go into the Porch code, you will see a lot of this going on. But I can tell you that the Porch code, I think, did kind of used a lot of stuff from Sample API server. And there's some cruft there, I think, stuff that you don't need. For example, they configure etcd there, but we don't store anything on etcd with Porch. I think that was just leftover code copied from here. That I'm very gingerly going to say that people maybe didn't understand that code when they copied it over. And that's totally understandable because it's a very opaque code and it's absolutely not clear that it has anything to do with etcd, but it does. So yeah, there's some probably cleanup we can do in Porch. But yeah. All right. Thank you very much for your patience with this. Again, hope it was helpful. And I'll see most of you tomorrow at the SIG automation meeting. Have a great rest of your day.
Yeah, thanks, Charles.
Thanks, Charles. Very, very thorough presentation. Thank you.
Okay, bye-bye.
Thank you.